Hey there, ever wish you had superpowers? The ability to lift crazy heavy things or move with incredible speed? Well, here's the wild part. You already do. And the secret isn't some comic book fantasy, it's physics. Today, we're going to dive into the simple machines that grant us these amazing abilities every single day. All right, let's just jump right in with a huge question. How in the world could you lift a car with just one hand? I mean, it sounds completely impossible, right? Like something straight out of a superhero movie. But it's a real-world problem with a surprisingly simple answer. You do it with one of these. This is the team, the whole crew. The wheel and axle, the lever, the inclined plane, the pulley, the screw, and the wedge. These are the 6 classical simple machines. And even though they look different, they all share the same incredible secret. They're the basic building blocks for pretty much every complex machine you can think of. So what is that secret? How do they actually work their magic? Well, it all comes down to one core concept. And honestly, it's kind of like a cheat code for physics. It's called mechanical advantage, and it's how we can literally multiply our own strength. Okay, first things first, let's get a couple of terms straight. In physics, the load is just the thing you're trying to move. It's the car, that heavy box, whatever it is. It's the resistance you've got to overcome. And effort? Well, that's you. That's the force you put into the machine. It's you pushing, pulling, or turning. It's your muscle in the game. So, pretty simple, right? The load is the problem, and the effort is what you do about it. And that brings us to the master key, mechanical advantage, or MA for short. All it is a simple ratio of the load to your effort. But what that number tells you is exactly how many times the machine is multiplying your force. Think of it like the machine's superpower rating. And this whole idea really breaks down into 3 main categories. If your mechanical advantage is greater than 1, you've got yourself a force multiplier. That car jack is a perfect example. You put in a little effort, and it lifts a massive load. If the MA is less than 1, you have a speed multiplier, like a pair of scissors. Your hand moves a short distance, but the blades snip a long way, super fast. And if the MA is exactly 1, the machine is just changing the direction of your force, like the pulley on a flagpole. So let's put this stuff into practice. We'll start with what is probably the most famous simple machine of all time, the lever. It's all about using a pivot point, what we call a fulcrum, to your advantage. This is a Class 1 lever. You can see the fulcrum, the pivot, is sitting right there between your effort and the load. The classic example is a seesaw, right? Or using a crowbar to prise something up. What's cool about this one is that it's the most versatile. Depending on where you put that fulcrum, you can make it multiply force, multiply speed, or just change direction. Next up, we've got the Class 2 lever. See how the load is now in the middle, between the fulcrum and where you're putting in the effort? A wheelbarrow is the perfect example. The wheel's the fulcrum, the heavy stuff inside is the load, and you lift the handles. Now, these are always force multipliers because you're always applying your effort farther away from the pivot than the load is. And finally, we have the Class 3 lever. This time, your effort is in the middle, between the fulcrum and the load. Think about a fishing rod or a pair of tongs. Now, with these, you actually have to use more force than the load itself, so its MA is always less than 1. So, why would you ever use one? Simple, speed and range of motion. Okay, so we've gone from pivoting things to lifting them. Let's talk about pulleys. These are basically just wheels and ropes that let us redirect force and lift things that would be way too heavy to move otherwise. Let's start with the 2 basic types. On one hand, you have a fixed pulley. Think of a flagpole. It doesn't actually make you stronger. Its MA is just 1. All it does is change direction, so you can pull down to lift something up, which is usually easier. But a movable pulley, where the pulley itself moves up with the load, that one actually doubles your effort. It gives you an MA of 2. But here's where the real power kicks in. What happens when you start combining them? You get this amazing setup called a block and tackle. Every extra rope and pulley you add to support the load can increase your mechanical advantage. It's like you're sharing the weight with more and more helpers. With 5 ropes supporting the load, like in this system, you get a mechanical advantage of 5. That means for every 1 pound of force you pull with, you're lifting 5 pounds. You are, quite literally, 5 times stronger. This is how sailors used to hoist giant sails and how massive cranes lift steel beams today. So, we've seen these machines in our tools and on construction sites, but the most sophisticated, most common machine that uses all these principles is one you're using right now. In fact, it's you. That's right, these simple machines are built right into your own body. Let's start with a Class 1 lever. Just nod your head right now. Your spine is acting as the fulcrum. The weight of your head is the load, and the muscles in the back of your neck are providing the effort to pull it back up. It's a perfect Class 1 lever. Okay, how about a Class 2 lever? Just stand up for a second and raise yourself onto your tiptoes. The balls of your feet, that's the fulcrum. Your entire body's weight is the load, right in the middle, and your calf muscles provide the effort to lift it all. It's an incredible force multiplier. And what about Class 3? Well, look no further than your own arm. When you do a bicep curl, your elbow is the fulcrum. The weight in your hand is the load, and your bicep muscle, which attaches right in between them, provides the effort. This one isn't designed for strength. It's designed for speed and a huge range of motion. So it turns out the physics of superpowers isn't just in some far-off laboratory or in our toolboxes. It's literally in the way we move, walk, and live. The next time you open a door, ride a bike, or even just take a step, take a second look. You'll start to see them everywhere. So what other simple machines are hiding in plain sight?